Okay, now we have the green light. So last session of the afternoon, hope you are not tired for this slightly technical session. Anyway, I'm Marcello Dorazio, project manager in the methodological directorate here at Istat. And we have 3 presenters in the session, 2 from Istat and Clement from the Swiss Federal Statistical Office. So I leave immediately the floor to Clement, that is already in the presenter chair. So 15 minutes for the presentation, and then, as usual, question from the floor. Clement, the floor is yours.
Thank you. So my name is Clément Chevalier. I'm working in the Swiss Federal Office of Statistics, so that's the National Institute of Statistics for Switzerland. And today, I wanted to talk about robustification in survey sampling. We have the slides? We do. So I wanted to talk about robustification in survey sampling, yes, because in Switzerland, we are not giving up on surveys. We will be doing surveys here. It will be about surveys. I will talk about a case study of adapting an academic method to the Swiss value-added statistics, which is obtained with a survey. So what is this survey? The Swiss value-added statistics. It's a survey performed every year, a yearly survey with approximately 23,000 primary units, so that's companies. A few of them respond to the survey, and they respond some variables of interest. The most interesting variable of interest is the value added, so the quantity of wealth produced by the company. So I want to talk about the weighting method, how we give weights to these 15,000 units. Here you have an overview of the process. So we go through 3 steps. We first choose a response model, and after the response model, we have some weights for each unit. I call them DI. Second step is the robustification of the weight, which transforms some of the weight DIs into new weights, DI star. And in the end, we rely on calibration. So these auxiliary data, this financial data, this tax data, we use them, but not to replace the survey. We still do a survey, but we use them in this calibration step. So the focus today, I'm not going to talk about, it's interesting, but I'm not going to talk about the response model, how we give a probability of response to each unit. I'm not going to talk about the calibration match. I'm going to talk about the second step, the robustification of the weights. So a quick word about the sampling design. We do Poisson sampling to build the sample. Poisson sampling with homogeneous survey rate within some strata, and the strata are built by crossing the NACE and the size class that's built depending on the number of employees of each company. Okay, you have some details about how this sample is built. Unfortunately, it's in French. So, but it's public. It's in a methodological report, rapport de méthode, publicly available. So, as I was saying, this weighting process, so to give weights, we have 3 important steps. The first one, we have a response model, which gives the probability of response, Ri, to each unit. And from that, we have some weights, Di, for each responding unit. So this probability of response, obviously, it's estimated from a model. The second step is the robustification. That's what I'm going to talk about. So essentially, if you want to think about this robustification, in a few words, it consists in downweighting what we consider to be influential units. So units which are considered influential, we want to reduce a bit the weight that they have. We never upweight a unit. And the third step is the calibration using auxiliary variables. And after the calibration, we have our final weights. So what is the motivation to apply some robustification? So in the survey that we use calibration. And in particular, we have one variable which is fairly good to predict what the companies are going to respond. It's what we call the VAT sales. So it's released from tax data. We know how many VAT the companies have paid. And if you know how many VAT they paid, you can have their total sales. But unfortunately, we have this only from the previous year. So if we are in 2025, we have the data, the VAT sales of 2024. We don't have them from 2025. So that's not going to perfectly predict the response of the company. And moreover, the response of the company is not only the sales. There is the value added, for example, and the value added and the sales, they are correlated, but it's not the same. It's not the same. But still, it's a good linear predictor. However, it's a good linear predictor. However, for a few units, it really fails to predict the response. And when you do a linear regression, when you predict the response using this variable, you have some residuals, and for some units, this residual is large. The problem is that when you calculate the variance of the total, for example, the total of the value added, this variance is directly linked to how big these residuals are. So if some companies have huge residuals, epsilon I, because we failed to predict what they were going to respond, your variance is going to be high. And when you look at this formula depends also on the weight, that DI that we give to the company. So when the residual is large, it might be very tempting to downweight the company I, which has a large residual. Just take a look. If you put the weight to 1, DI minus 1 is equal to 0. No variance, we win. So that's why robustification could be interesting. Obviously, when you do that, this weight DI, it's the weight which enables to obtain something which is supposed to be unbiased, more or less unbiased. When you downweight the unit, you create bias. So you are going to win on the variance, but you are going to lose on the bias. You don't really know exactly how much you are going to lose on the bias. So how do we want to robustify? So there is an article from Jean-François Beaumont from Statistics Canada. He suggests to identify the units using the notion of conditional bias. And he defines what the conditional bias is. And he says, well, we could downweight the units which have a conditional bias larger than a threshold, which he calls C star. And the conditional bias in our case, it's this quantity. So it depends on the residual and on the weight. If you have a weight of 1, no conditional bias. If you have a large weight and a large residual, you have a large conditional bias. So that's a quantity which we found interesting. And Beaumont, yes, he proposed an estimator which can be interpreted in terms of weight, and I'm going to detail this point. So what Beaumont proposes in terms of weight, that would be to select all the units which have a conditional bias larger than a threshold, C star, and to downweight them. And he says how to compute C star. Okay, that's not really the problem. His interpretation is to say, well, you downweight them, but how much? You want to downweight them by a factor, and actually you want to reduce the distance of the weight to 1. So you still have a weight which is more than 1, but you reduce the distance to 1 by this quantity. And this psi here, you need to just imagine that it's C star. It's your threshold that you have fixed. And here you have the conditional bias. So for example, if your conditional bias is twice as much as the C star, you are going to reduce by 50% the distance of the weight to 1. You're going to make it closer to 1 by 50%. And yeah, that's a small picture. So that's one possible interpretation. And another interpretation is to say that using his estimator is equivalent to downweighting not 1 but 2 units. The one with the most positive conditional bias, so a unit which responds more than what we're saying, and the one with the most negative conditional bias, so a unit which responds less than expected. So you take somebody who responds more than what you thought, somebody who responds less than what you thought, and you don't weight both of them. And by how much? Well, you reduce the distance of one by a factor 1/2. So that's the second interpretation. And some remarks. So the first interpretation has an advantage, which is that you are going to downweight more when the conditional bias is large. If you have a huge conditional bias, you are going to reduce the weight to essentially 1. And if the conditional bias is really close to C star, you are not going to reduce the weight so much. The second interpretation, you reduce the weight. The weight reduction is more simple. You just take the distance to 1 and you halve it. Simple. Your weight was 5, you make it to 3. The distance was 4, you make it to 3. Simple. And you don't weight units by pair. And yeah, the pairs are formed with a unit which responds more than expected and a unit which responds less than expected. 5 minutes. Thank you, Marcello. In a way, that's quite tempting to say, hey, I'm creating bias, but I'm reducing the weight of somebody who responds more and the weight of somebody who responds less. So maybe I will benefit from some kind of compensation effect by doing that. The drawback of both methods is that the number of downweighted units is not really controlled. And in practice, we may want to downweight more or less than units than what the method suggests. So in practice, maybe these slides, I can go quickly through them because this is how we implemented that for the value-added statistics. We have not one variable, we have many variables. We don't do just one estimation. Obviously, we do estimation by domain, typically the NACE. And so we would like to apply a robustification inside each NACE and for each variable of interest, not only the sales or the added value. We applied some kind of algorithm. I'm going to skip this slide because the details are really in the paper, and I'm going to jump to some results. Okay, how many units did we downweight? Is it a good idea to downweight units, or should we avoid doing that? So for the survey of year 2021, out of the 15,000 weights, the responding units, we robustified 110 units, meaning that we took 110 units and we downweighted them. So that's 0.7% of the units. You might think that's a lot. You might think that's not that much. Okay, what's the actual impact on the result, on the extrapolation? Well, when we evaluate the total of the added value by NACE, here in this column, you have the impact of robustification. So we calculated the totals with and without robustification and compared the two. And you can see that the impact is generally small. Well, in this NACE, but it's a small NACE, only 1 billion of added value. So robustification had a negative impact. And in the last two columns, you have especially the last column, you have did this robustification actually reduce the coefficient of variation of what we are estimating? We see that not much happens in many NACE, and in some NACE, for example, here, we have a coefficient of variation of 1.9 without the robustification, and we can improve it by 0.3. So with the robustification. Yeah, this is here again the results by the impact of the robustification. So you can see also that the robustification, it's not going necessarily to reduce the estimation of the total. I can find some positive numbers in there. And actually for all Switzerland, the robustification increases slightly the total. Yeah, this is because you are downweighting units, but after that you have a calibration, which is going to modify again the weights. So because you might say, hey, we just downweight units, so if the weight is less, the total is less. But no, you have the calibration which comes after. Okay, so conclusion. So for the Swiss value-added statistics, the robustification had maybe a moderate impact on the extrapolated results for the majority of the economic activities, NACEs. Currently, we downweight 0.7% of the responding unit, which is probably still a bit too much. I talked with the author of the paper, Jean-François Beaumont, and essentially his message was, okay, you need it, but try to use it as little as possible. As little as possible. That should be your goal. Try to avoid using it and use it only when you need it. So what is some possible future work? I didn't go into detail about how I chose the threshold for robustification, but that's definitely a topic. Jean-François Beaumont suggests that we could use robustification and calibration in one single algorithm. At the moment, I robustify, and then I have calibration. And you could maybe do both in one algorithm. That's quite a challenge. And yeah, the goal of this presentation was to say what we do here in Switzerland, and hopefully trigger some reactions, like what are you doing? That's not. The goal today was really to see your point of views. Are you downweighting your data? Are you downweighting the companies which respond something unexpected? Or what is your process? I'm curious to have your thought about that. So thank you very much. And I'm very much open for questions.
Thank you, Clement. So we have obviously room for questions.
Thank you for the very clear presentation. I have a longish comment which comes from reading the last part of your paper, and it appears here too, namely this that you should do two things in one. So the longish comment. I know several statistical institutes that apply calibration without checking that the preconditions are applied. It's applied rather automatically. I mean, the preconditions are that the auxiliary variables can predict participation, and they are for non-response, calibration for non-response, can predict participation and can predict also the variable of interest. And sometimes it's not checked and so on, and there are cases where calibration can actually make the things worse, bias things more. And I'm saying all that because I was following at the time when I was following these things, I was following this field, and I know of an article by one of the other co-authors of the paper that you are referring to, namely David Hasita and Eric Lesage, that was published in 2016 in JOS, which basically shows it discusses only discusses the calibration for non-response, which can be done in two stages. First, have kind of they discuss, if you find this paper, a two-step approach and one-step approach. And the paper, they show that the one-step approach can lead to really not good things. And when I saw what is written here, so, is it also going to be something similar? So a recommendation from my side is check this paper by David and Eric Lesage and see why the one-step approach is not good, because maybe there is some reason there that can for that. Maybe here also maybe it will appear here too, because you have in the beginning you have non-response, and then you have this what you are doing, and then in the end you have the proper calibration. So look at that, because I felt a little bit afraid of when I saw this, that you plan to do everything in one step. Maybe it will repeat what they found there.
Yes, thank you. That's Lesage on Aziza. That's it. That's okay. 2016. Thank you.
Other questions?
Yeah, you said you did your weighing on the NACE group. But on what digit level of the NACE group, and what size class seemed to be 1 digit? But
Yeah, we did this robustification at the NACE 2 level. Yeah, at the 2 digits NACE level.
yeah, I was a bit afraid of that when I saw your results.
Hmm?
When you showed your results with the 2 digit, and then I thought, oh, there are some groups which are quite different with regard to turnover. For example, if you, for example, the wholesale trade, then the 461 has way less turnover because it's more a service, and the other ones are really trading. So I think you can gain a lot by making the group sometimes a bit more specific than just 2 digits.
Yeah, that's a very good point. And the NACE 46 is a pain. Is a pain to deal with. I don't know if it's specific to Switzerland or if it applies to every country. That's a NACE where for example, the VAT sales, these fiscal data, they are extremely poor to forecast the actual response, even the sales, just the sales from the survey, your total sales. This VAT data, I think there is a problem of definition maybe in this NACE, because we have a lot of trading companies in Geneva, and they report VAT sales which are absolutely huge. Like they are 3 employees and they have, I don't know, 60 billions of VAT sales, and yeah, that's really, you're right, and so it's not. You're right. That's not all the NACE 46, and that's it might make sense to go to the 3rd or maybe 4th digit for some NACEs, yeah, rather than just taking all the 2nd digit NACE, yeah.
Yeah, so I think in the results you see for a lot of 2 digits it works fine, huh? Then your robust impact is already like 0.00. Or very low, but in the cases where it's very high, I think you can maybe look at the turnover from VAT first and then see if you can make better groups.
Yes,
I hope that's a quick win here.
Okay, so if there are no other questions, I will say that we are just in time for the second presenter, Anna Ciammola from Istat.
Thank you, Marcello. Good afternoon, everyone. The presentation I'm going to show you is the result of work that was done when I was in the Directorate of Business Statistics, Economic Business Statistics, and it was done with my colleagues Giuseppe Amato and Danilo Orsini. It is aimed at describe an automated framework for data validation and imputation for large enterprises whose data are affected by corporate events, and the domain is that of short-term statistics, obviously. The presentation is divided into 4 parts, and let's start with the first part, what makes managing large enterprises so complex. Obviously, their relevance, and this is measured through unnegligible contributions to growth rates of aggregated indices. But there are also several factors, other factors such as the fact that large enterprises often work on 2 or more niche sectors, and this means that several kind of activity units CAUS has to be managed in the activity of the surveys. They are often involved in corporate actions or events, and often outliers that are detected during data validation activities mostly are correct data, and these they cannot be modified or adjusted, much less in an automatic way. To give you an idea of the impact of a corporate event, I show you this scatter plot where the reported turnover of in the year 2018 and 2019, sorry, and the red triangles represent an enterprise whose turnovers are affected by an event. And this increase in turnover, in the level of turnover, is not the only effect, because in this slide I show you that the event produces a change in the business model with these effects on the domestic and non-domestic turnovers of the enterprises. So after an event, there are breaks in time series, and these breaks make data validation imputation very challenging. The problem in short-term statistics is that no auxiliary variables are available for using more sophisticated methods, so only temporal information can be used. So we can use for data validation or imputation, month-on-month growth rates or year-on-year growth rates. The first ones are unsuitable for some kind of variables like production or turnover due to their marked seasonality and volatility. And so the tool that we can use is year-on-year growth rates that have the problem that they point out the same anomalies over 12 months. We can skip this slide. And so what we want avoiding repetitive and unnecessary alerts during data validation when we use year-on-year growth rates. We want to maximize check effectiveness, and we wanted to estimate missing data by taking into account past events and outliers. What we want to do is a fully automatic neutralization of breaks in a time series of turnover or production or other kind of variables. cumulative variables. Building on the past example, what we want is to simulate this data and this data for non-domestic turnover. How this can be possible? We created a very simple tool in the new system, application system used for turnover surveys. It's a table included in an Oracle database, and we called this demography table, and it can be considered a game changer for the events management in synthesis. That is this application system you introduced for turnover surveys. And it contains a series of several information, systematic storage of events, information to calculate simulated data, and chain of events. That is, events that, 2 or more events that happen over a period shorter than 12 months. This is a simplified layout of the table. It contains 3 pieces of information. The first one is firstly the identifiers or enterprises involved in the event. The second kind of information is 2 pairs of dates, and the third kind of information is the quantitative coefficients that are used for calculate simulated data according to this formula. This is an example of a spin-off, how it is represented in the demography table. And this, the red line represents the simulated data. Where we have a chain of events, so we have 2 or more events in the same year, in a period shorter than 12 months, the situation is much more complex because we have to upload the previous, update the previous information and then upload other information. And the result of the simulated, of the computation of the simulated data is the dark red time series reported in this graph. We show you an application on micro editing on the survey of turnover of services, and in this table is reported a selected output of the macro editing interface of the application system synthesis, and for 2 units, and the information reported here are refers both on to observed data and simulated data. As you can see here, the first unit is a bit is considered an outlier In fact, its year-on-year growth rate is larger than 100%, and we can see that it is considered an influent outlier looking at these two information indicators, infra and HB, that are checks included in the application system. Using simulated data that are generated automatically by the system, you can see that the observation is not considered outlier any longer, and the year-on-year growth rates becomes negative. To conclude, I show you some pros and cons of this tool. The main pros are the speeding up of data validation and imputation, minimizing human interventions, improving quality of short-term indicators. It is independent of validation and imputation methods used, and it can be used also when the electronic invoicing is introduced. This because invoices cannot catch information on kind of activity units and underestimate non-domestic turnover. The main concept is that is the fact that they will require some time for updating or appending information, especially when chained events have to be managed. Thank you very much.
Okay, thank you. Thank you. Okay, thank you. You finished earlier than expected, so we have more time for questions from the floor. Are there questions?
Thank you very much for the very nice presentation. I was very curious to, could you give some details about the model which is used to make these imputations in time series? I was wondering if there is some kind of ARIMA models like
imputation is based on the use of year-on-year growth rates of the respondent units yes, for the most detailed level.
Questions?
The use, the ARIMA model, sorry, only one thing. ARIMA models generally are not suitable for this kind of data because they are data for enterprises. They are too irregular, and ARIMA models are not is not the correct tool.
Okay. My question is, if do you think this approach to handle corporate events like mergers and so on could also be generalized, for example, to other short-term surveys, for example, industrial production survey or short-term industrial price surveys and so on. Thank you.
This approach can be used for cumulative variables like turnover, production, employees. Obviously, it cannot be used for prices or variables that cannot be cumulated.
So maybe I can do a question. So basically, my question is, have you done any study about the sensitivity of outlier detection depending on how you backcast the series? So it is important practically to have a precise backcasting, or to outlier detection it is sufficient having just a rough prediction of the reconstructed series?
For outliers, it's the back forecast is necessary because of the methods of imputation used. So we year-on-year growth rates compare to observations. If the previous observation is affected, is an extreme value, obviously it affects the imputation. More sophisticated methods can avoid the use of backcasting because it could avoid the use of past information. But it's possible with surveys collecting information on several dimensions, on several variables. For example, the survey on large enterprises. Not for a production survey or turnover surveys, because turnover is the only variable collected.
I don't see other questions, so it's time to the third presenter, Fabiana Rocci from Istat.
Microphone. Good afternoon, I'm Fabiana Rocci. This presentation is on behalf also of my colleagues, Veronica Rondinelli, Gabriele Paone, Stefania Fivizzani, and Cristina Ciaffararà. We worked all together as different competence to the re-engineering of the monthly survey on large enterprises. We're going to show what we did, what we achieved. The presentation will go through a description of the survey. So we will have a look on the statistical process, so how the ideas for innovation were born. Future of the editing scheme was in a way at the core of the redesign. So we show the ideas, the implementation and results together with the IT architecture description, what was obviously important to achieve what we wanted to do. And then conclusion. Okay, we also talk about the larger enterprises, but this survey is run only on large enterprises. It is based on a census panel of large enterprises, defined as enterprises with at least 500 employees. We have a total amount of about 1,700 units. They cover only the 0.1% of total number of firms in Italy. Keep in mind that in Italy we have very large amount of very small enterprises. Obviously, they cover quite important amount of employment and turnover, 22% of employment, 26% of turnover. This survey releases several kinds of data within only 50 days from the reference period. It releases index at the aggregate level of the main variables, employment, work hours, wages, and labor cost. But it releases also microdata about job vacancies and wages and labor costs to be integrated in other sources, in other processes, sorry. So to create multi-source processes. This implies that there is a need that the quality of the final data are requested to be reliable at microdata level. The process has been redesigned, both from the IT and the methodological point of view, and we go through what we did. The statistical process, the flow. Obviously, we start from the respondent. They send a questionnaire, online questionnaire, on which there are only soft alerts, and they send the data on the enterprise portal. The data goes into the internal DB, and we have several tables. We go from the raw data to the validated data with the core interactive micro-editing. This at least as it was for very long period. Once we go to the validated data, we have the non-respondent estimation, then estimates of aggregates on which we run, we release the indexes on which we run the macro editing. We see this cycle that from interactive macro editing, we go to was run by a group of thematic experts. They could validate data, otherwise they could also correct data, or to recall the respondent to ask for explanation, in the case to ask them to resend the questionnaire. From the macro editing, in the case they would find still some error, they would go back to the micro editing and then go again, correct, validate, or to recall the respondent. Once the indexes are released, they go to the seasonal adjustment to release the finally also seasonal adjusted series. All the seasonal adjustment processes run on other server with other software. So from the methodological point of view, the core of the redesign was about to redesign the macro editing phase to achieve a new approach and to introduce a selective editing phase. From the architecture and project point of view, obviously, the first point was to support the redesign of the micro-editing scheme to incorporate the controls and check into the process to be as far as possible automatic. Then they had to handle a lot of other problems, like to create a new system to incorporate a robust logging and monitoring framework to guarantee transparency, traceability, and continuous optimization of the process. And to build a centralized interface for managing relationship with companies and to ensure secure and validated communication with multiple platforms. The future of the editing scheme. Even though it's a monthly survey, we, because I used to work at this survey, now I'm as a support, as a methodologist. Anyway, we survey a lot of variables. We have a number of persons employed, the number of worked hours, basic and overtime, basic salary, all parts of added salary, whole salary and labor cost, all breakdown by workers and white collars. How was the editing scheme? Every expert told you we had a group of mathematical experts. Every expert was in charge of a certain number of units. Online form to check every questionnaire. On every questionnaire, characteristic parameters are elaborated: per capita wages, per capita work hours, incidence of overtime, and so on. There were about 20 edit rules, some based on the comparison of the characteristic parameter on the longitudinal basis of some variable, from some other on given benchmark. The final aim was to monitor the reason of strange data. Experts were expected to assess whether a strange data was an error or a true anomalous data. They should recall the respondent in order to better assess the nature of the data failing edit rules. How we started to design, to think about the new scheme. We did a lot of analysis by comparing raw and validated data on the historical series, because this survey has got very long series. Results, what was showed? On average, about the 50% of questionnaires did not fail any edit. On average, less than 10% of questionnaires were changed in at least one field. Very low percentage of units were changed in many fields. Most of changes were done on two types of variables: number of worked hours and taxes. That means that they could be classified as systematic errors. Difference between raw and correct data affect validated final data, affect in an important way the total amount of the variable only for specific variables and only sometimes. Most of failure of edits were hiding anomalous data, hence correct but not errors. So what we thought, this is an optimal picture of data. We consider this to be very high quality. In this way, there is a large space for an efficient change, maintaining high quality of data. So first moves. Move from a one-to-one questionnaire check to an automatic program that would run the edits over all the questionnaire. We set as a result the list of all the respondents with number of edits failed and values of the characteristic parameters, not value, characteristic parameters on which the edits were run and elaborated. From the list, it was possible to select the record to be assessed. Further improvements. We set stricter threshold in order to result in less but more efficient alerts. The new scheme was tested according to different rules and thresholds. Final decisions were taken together with the thematic experts who ran several tests on edits, alert, and automatic correction. Because we decided at first to set automatic correction for systematic errors. As main reflection anyway, was to keep in mind that to give explanation for anomalous data was still necessary, because most of the alerts were not errors, but anomalous data. Not everything could be done automatically. To insert, finally, a further step to select potential influential errors before the run of the aggregate estimate to minimize the effort into the macro editing. What was at the core from the IT point of view and as an instrument for the manager was the dashboard, the data browser. This is all the IT architecture, what they did. I beg apologize, I don't really go into this, but we have the colleague here. Anyway, they release a program and a specific job for automatic controls, for manual reports about respondent, complex anomalies, and so on, and dynamic configuration to be flexible. What was very important, and we agreed about this, is whatever we released to the manager was to be flexible, both from, for example, about threshold and so on, and to be, they could do on their own with IT instrument. So the automatic execution, and there was something manual execution, as for example, the custom parameters, on-demand processing and management of special cases. What the thematic expert feedback was in the final setting: automatic correction and systematic errors were cancelled. They prefer to insist to recall the respondent to ask for correction by resending the questionnaire. In most cases, they were right, it worked out, resulting in a strong decrease of the systematic errors. In what we call the stubborn case, they will ask for hard alert on the questionnaire. The threshold were further adjusted. Some further controls were added, some cancelled. The selective editing before the estimates resulted in helping a lot to avoid further alert and recall at the very end of the survey. Strong is the belief that contacting the company directly allows to determine whether it is actually an error or anomalous, and above all, to assess if a demographic event has happened. As a conclusion, the engineering was designed on the basis of many analyses of the historical data and many tests. Many decisions were taken based on simulation of the validation process, testing the new process against the old one. It has been implemented in a way that could change, the manager could change a set properly threshold, could implement further edits and manage efficiently the survey. This resulted to give a chance to optimize the human resource in recall respondent and collect information about data. In the meanwhile, achieving a better quality of the data at the input level. Thank you.
Thank you, Fabiana, for being perfectly in time. So we have room for questions from the floor. Okay, if not, maybe I will ask a quick question. So it seems to me that your work of looking at the historical data was impressive, and it seems a good ground in which, for instance, you could also try to test having such an amount of data for training of method like, modern method for detecting influential units in a multivariate setting. So in my small experience, I've seen that in financial data, banks are using a lot this new tool that is the isolation forest, which seems very promising with variables and returns out a score that ranges from 0 to 1. And so values, greater values, higher risk of having a multivariate outlier, then you have tools to identify which are the suspicious variables. So having such an amount of data in the past, maybe it could be worth trying a test. And just to add something, being back after many years to outlier detection, what is interesting recently is that Statistics Canada, that had an impressive work in this area, and that released the famous system BANF for the SAS, recently decided to release everything in open source Python format. So nowadays, almost all the software implemented by, so methods and software implemented by Statistics Canada are available as open source software in Python, freely available on the web. And so they have done an impressive work for editing and imputation. And so I think that is a good occasion also to take stock of the work done by them.
When I was working with them, I was working in the meanwhile also on something like this on other surveys. And so we started with this idea, let's use some modeling, probability modeling, also machine learning. It is very good. You have a lot of training data and very good training data. The point is that we had to re-generalize it. And once we did all this analysis, we had such a good result where errors are very, very low. And most of the time are anomalous data. And the group of companies is very small. If you think about it, it's only 1,700. It was, the effort on putting the error they have, that's why I underline their systematic error. Modeling is about probability error. So we designed that in a very, how can I say, not sophisticated way, but it was very efficient. Letting for the future, we would like, what I would like to work with them once they're stable with the survey, to look for new edit rule, because they have a lot of edit rule. It's sometimes, how can we say, it's a burden for them to check too much edit rule. We would like something, I'm working in other service to use this kind of model to look for new edit rule in a way to, how can we say, to identify outlier in a more efficient way according to the specific characteristic of these variables.
Okay, other questions? If not, Pasquale, last question.
Me too, very quick questions. Just if you considered during the redesign process the possibility to use alternative sources, for example, administrative or other kind of sources. Thank you.
This survey, microdata from large enterprises is integrated with ORAS based on administrative data. They started many years ago. They were at the very beginning of the use of administrative data, and they checked a lot together if it was worth to do everything with administrative data or not. They had at the beginning two kinds of problems. First of all, the survey is much faster than the administrative data. Now, administrative data more or less is at the same time, but the main problem is who do you call when you have strange data on large enterprises with administrative data? Because most of the problem is to explain every time they release data, they have to explain why the break and the series, because also when they integrate this data with ORAS, ORAS releases data on index on all the economy, still what happens in the large enterprises affect the final aggregate. So this is how can I say, is a decision from the management point of view. Also, it was very strong still now after what happened with the COVID, that the large enterprises was the survey who they have such a good contact with them, is so stable that it was such a good, how can I say, the core of all the department. So it's more than the quality is about the management of data and to explain what happens, because most of the time is something strange. I mean, it's about the cycle and so on. It's not about errors.
Okay, so we are not in time, but earlier than expected. But at this point, I will, if there are no other questions, I would close this second day of conference. I guess that there will be some communication from the colleagues for the tour and the other organization method. Thank you.
Yes, thank you. The communication for today is that the guided tour will start at 5:20 from the entrance, so be sure to be there in time, and Silvana will check who is there in order to know if there is anyone missing. And for the other ones that are going directly to the restaurant, I don't know if there is any case. We can meet at the restaurant at 7:45. It's Largo dei Chiavari 84, close to Campo de Fiori. And so if you need the address, I will give you directly. See you downstairs.